Okay, so this is exam 4 review for Organic 2, spring of 2016. So like that. So the first thing you're gonna have to do is we're gonna have to name some compounds, right? So with that, so for here, right? So go ahead, put in your dots. Right? So with that, so don't forget that the main chain is gonna have to include that functional group there. So in this case, it's an acid chloride, right? So it's 1, 2, 3, 4, right? You have 1, 2, 3, 4, 5, right? So it'd be bigger or be longer, right? But it doesn't include this group. So we're going to take this one here. Now it wouldn't matter if you took it those four, it'd be the same thing, right? So it's right. So it's 4 long, right? So it'd be butane, right? But for the acid chloride, right? So it'd be butanoic, or excuse me, butanoyl chloride. Okay, and we have this methyl group here. Right, so the right, so the numbering is going to start here. So 1, 2, 3, 4, right? So with that, so it'd be off of carbon 2. So this becomes 2-methyl butanoyl chloride. Now, if there was a bromine here, you'd be butanoyl bromide. If it's an iodine there, it'd be butanoyl iodide. There we go. Okay, so now for okay, so this right here, this is an anhydride, right? So first thing you got to do is you got to check the sides. So you got to check that side, you got to check that side, right? So here, right, this side has 4 carbons, this side has 5, right? So it's not symmetrical. So that means you're going to have to name both sides. Okay, so the left side here, right? So left, right? So 1, 2, 3, 4. So C4, right? So it becomes it'd be butane, right? But you name it like a carboxylic acid, so it'd be butanoic. Butanoic, right? This side here would be 1, 2, 3, 4, 5, right? So the right side would be C5, right? So it'd be pentane, but we take off the E and it'd be pentanoic, right? So then we look at just the main chain. So by that, so butanoic versus pentanoic. Butanoic comes first alphabetically, so it becomes butanoic, pentanoic, anhydride. There we go. Okay. Okay, so for here, right? Notice how both of these, again, it's an aldehyde or it's an anhydride, but it's symmetrical, right? Both sides are the same. You know, so we really only have to name the one side. Okay, so this one here, a carbon with a benzene with 1 carbon away. So this would be, if this was an OH, it would be benzoic acid. Okay, so it'd be benzoic, right? So if that was an OH, it'd be benzoic acid. But since that group is benzoic, now it's benzoic anhydride. Okay, so with that, so okay, now for this one here, right? So for the esters, right? So they're always going to be, the name is always going to be, so the name is always going to be the O, whatever's hanging on the O, and we name this as a side chain, plus the C double bond O side. Okay, so the O side, right? So it's 2 carbons long, right? So C2, right? So it'd be ethane, right? But you name it as a side chain, so it becomes ethyl. Okay. This one here, right, the C double bond O side, right, so I'm going to do this in black, right, so 1, 2, 3, 4, 5, right, so it'd be C5, right, so it'd be pentane, but since an ester, we call it, down here, it becomes pentanoate, okay. So for this one here, the numbering is going to start right here. So 1, 2, 3, 4, 5, right? So it's going to C1 is going to be that C double bond O. So you have these 2 methyl groups, so methyl, methyl. They're both bonded at carbon 3, right? So so this part is going to be 3,3 dimethyl pentanoate. Okay, so the naming goes this part here, so ethyl, and then this part 3,3 dimethyl pentanoate. Okay. You don't have to put the parentheses, but it sometimes it's easier to see if you do. Okay, so for this one, okay, so for the amides, okay, so for that, so you only really care about the main chain here, so on the C double bond O side, right? So look for the longest chain, right? So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so it's not going to matter. So this is going to be our main chain on the C double bond O side. Okay, so it's going to be 5, right? So C5, which would be pentane. Take off the E, and the main chain is going to be pentanamide. Okay. Now the rest of these things, this one here, we're going to have an ethyl, and then here it's a 1 carbon piece, it's a methyl. Now we don't care about the hydrogen. We can assume that if there's only one thing hanging off the nitrogen, the other thing's going to be a hydrogen. Okay, so here we go. So for the ethyl, right, so the numbering again starts at the C double bond O, so 1, 2, 3, 4, 5, right, so that's hanging off of carbon 3, but this one is hanging off, the methyl is hanging off the nitrogen, so we say that's in. Okay, so right, so ethyl comes before methyl, so it's going to be 3 methyl in, oh excuse me, 3 ethyl, in methyl pentanamide. Okay, so our main chain is on the C double bond O side. Main chain is 5 carbons long, has an amide in it. Okay, it also has a methyl group hanging off a carbon off the nitrogen. Okay, and an ethyl group hanging off of carbon 3. Okay, so the 5 carbons long, 1, 2, 3, 4, 5. Right, it has an amide group here. Carbon 3, there's an ethyl group hanging off of here, and off the nitrogen there's a methyl. Okay, so for thioesters, right? So thioesters, we name it the same as if we do esters, right? So we're going to do the S side, and then we're going to do the C double bond O side. Okay. So for the S side, right, it's going to be 1, 2, 3, 4, right? So C4, right? So it'll be butane. But we name it as a side chain, just like we did over here. So it becomes butyl. Okay, so for the C double bond O side, right? So this one here, right? So just like this one was benzoic, okay? Just like this was benzoic, this becomes benzoate. Oh, excuse me, not benzoate. If that was an ester, regular ester, benzothioate. Okay, so if it was just a regular ester, it'd be benzoate, but the benzothiate, this means sulfur. Okay, so we're going to put this in front, right? So it becomes, excuse me, butyl benzothioate. There we go. Okay, so for the reactions, right, you're going to need to know this list, right? So carboxylic acids, acid chlorides, anhydrides, thioesters, esters, amides, right? So go down this list: acid chlorides at the top, anhydrides, thioesters, esters, amides. Okay, so know that you can go down this list, right? So acid chlorides can make any of those, anhydrides can make any of those, but you can't go up. Now you can go side to side, so you can go from one thioester to another. That's fine, but you can't go from a thioester up to an anhydride. Not easily. Not assume you can't. Okay, not with this chemistry. Okay, so know this list. Okay, so for here, right? So here you're going down. Either carboxylic acids are sort of semi-equivalent to esters, so you can have any of these to go down here, right? You can't go from amides up, right? So everything's kind of coming down here. If you have a water here, so you can all the way down here. So any of these will go, and any of these will go if we're making an amide, right? So with that, so to make an anhydride, right? So with that, so here, right? So you basically go from an acid chloride down here, and so you have this group. You can also do a carboxylic acid here to be able to attack up, down, kick away chlorine to make the anhydride. Now, how do we make the acid chloride or acid bromide? So for those, we have to we use either thionyl chloride, right, because that converts an OH into a Cl, OH into a Cl, or PBr3, where it converts an OH into a Br. Okay, so that's how we actually make the acid chloride. So like that. So okay, so like that. So now for adding carbon groups, okay, or adding hydrogens. Okay, now this doesn't affect amides. Amides are a separate thing, but all the other ones, what's going to happen is you're going to add the carbon group. Now methyl can be however long it needs to be, doesn't matter. Okay, you add the first one, it goes up, goes down, kicks this away. You're going to make, in this case, you're going to make the ketone here. Now this is chapter 21 chemistry. For what happens next is chapter 19 chemistry, where the ketone is still reactive. So another one of these is going to come up. So another one of these is going to come, right? So this one comes here, up, down, kicks away, right, to make the ketone. Now another one's going to come up and just go up and stay up. Now if it were to collapse back down, you're not going to break that carbon-carbon bond or that carbon-carbon bond. If it would kick off another one of these groups, you would just go back to here. So what you're going to end up being is you have an OH plus what attacked it. So you're going to end up with 2 carbon groups added. Okay, same thing that happens here, right? So this is just a source of H minus. So H is going to go here, up, down, kick it away. Now you're going to make the aldehyde, which is still incredibly reactive. So you're going to make another one of those, an H minus. But again, it only goes up, stuff like that. So to make the OH plus what attacked it. So you're going to end up, right? So here you had 2 carbon groups. Here you had 2 hydrogen groups. But essentially it's the same thing. Borane is just another source of this. Okay. Now amides give a different one. Okay, so the other thing you have to know that if you add a carboxylic acid and an amine just together straight, you're just all that's gonna happen is you're gonna get a nice acid-base chemistry here, and so this guy's just gonna pluck off that hydrogen, no problem. What you have to do is you have to include this compound called DCC, which is dicyclohexyl carbonamide, stuff like that. So that actually converts this into an ester, which basically effectively removes that, and so you get the normal up, down, do, and kick away, and so you end up with your regular coupling reaction, your amide. Now, the other thing with the amides is that with here, if you have the source of hydride, what ends up happening is not, you don't add it twice. What ends up happening is you rip away that C double bond O, and to end up being turning into a CH2. Okay, so that sort of goes away from your skeletal structure. Okay, that's one of the exceptions. Okay, so here we go. Okay, so for this one here, right, you're going to have this guy coming in attacking there, up, down, kick away, right? So you're going to end up with this. Fluorine is just there for fun, right? So O, and then everything else that was, right, all of this stuff is going to go along with it, right? This is just come along for the ride. Plus, when this thing leaves, it snatches that hydrogen, so your S, like that, your 2 carbon, your ethane thiol here. Okay, and just as a double check, right? So we're going from thioester to ester. We're good. Okay. Now for here, right? That's going to attack there, right? Up, down, kick away, right? So you're going to end up with there you go, plus HCl, right? So that CLS is, well, in this case it's Cl minus, right? So that would this would, you know, if there was a hydrogen here, it would rip it away, so you'd get HCl, but that's okay. This is the main thing here. Okay, and we're going from acid chloride to anhydride, so we're good. Okay, now for this one here, it's kind of hard to see, but right, so again, we're going to have that one come there, whoop, there, up, down, kick away, right? So you're going to end up with this, right? Plus methanol, right? So with that, so as this is leaving, it's going to grab that hydrogen, right? So we're going from ester to thioester, right? This one here, right? So ester, thioester, that's going up the list, right? So right, we're going up that list. Okay, that's not allowed, because what would actually happen is as soon as this would form, this would come back and attack to reform this. Okay, so what ends up happening is you just cross this out and say no reaction. Okay. Okay, so we have a carboxylic acid and an amine. If this was right, so with the and we have our DCC here, so we're good to go. So again, this is going to come in here, up, down, kick away. Right, so you're going to end up you can actually get the coupling reaction to work. So NH, and as this is leaving, it's going to snatch one of those hydrogens, right? So there's still one left. So like this plus water, HOH, right? Okay. So now here, right? This is a source of H minus, right? So that's going to attack here, up, down, kick away, right? To make, and this is symmetrical. Right, I'm going to give you, if there's a reaction, I'm going to give you a symmetrical one, right? So that would form that as an intermediate, right? But don't forget, that's still reactive, so you're going to get another one. Just goes there, and so you're going to end up with actually this, and then with two hydrogens attached. Okay, so here's your product here. Here's your final product. Okay, we're adding a hydrogen, right? So we're going to add it twice. Okay. Now for this one here, right, this is a source of a hydride, but notice the amide here. So when that happens, we're just blowing that away. Okay, so you end up with fluorine and then NH. Okay, you just remove that. Okay, so there you go. Okay, so for the carboxylic acid derivatives, okay, so we're going to get just something very simple. Okay, so let's just do an acid chloride, right? Plus methanol going to OCH3 plus HCl. Okay. So what I want to see is I want to see this tetrahedral. I want to see the tetrahedral intermediate, and I want to see that leaving group grab that hydrogen. Okay. And so remember, right? Lone pairs there, right? So, right, the reason why this happens is this is a polar covalent bond. This has positive character, right? So these lone pairs are going to be attracted there, which is going to kick that out. Right? So you're going to end up with your tetrahedral intermediate. Right? So we haven't done anything with that hydrogen yet, so there's a positive formal charge there, right? I need to see those formal charges, plus, right, so nothing's happened there, right? So now this collapses down to reform the double bond O, and in doing so it kicks off that chlorine, okay? But notice how we haven't done anything with that hydrogen yet, so it's still there. Plus Cl minus, right? Now these lone pairs come in, grab that hydrogen, push that away, and now you're up to there. That's all the harder it's going to be. Okay, so there you go. There's your mechanism. So good luck.